So I hope everybody can see my screen now.
That's fine. Yeah.
Perfect. So I have 1 hour to give you an overview about the Sentinel application platform, about Snap. This application platform is an open source. It's a free software that allows processing and analyzing satellite data from multiple sensors, but it's specifically related, or those related to the Copernicus Sentinel program, where it's more developed so far. As an overview, Snap can read many Earth observation data products and some generic raster formats too. It has great visualization capabilities and allows studying the data using tools for statistical analysis, mathematical operations, correlation, comparisons. There is a big Snap community. Right now, we are more than 1 million users, and there is a nice forum, a STEP forum. You can see the address here, the link here, and the forum already has more than 10,000 users. So it's really very, very active. Just to give you a background from where Snaps come from, the Sentinel toolboxes and the Snap development in itself started in 2014, but Snap had predecessors, Vim and Nest, the Nest softwares from ESA, starting already in 2000. That means we have these tools available for more than 20 years, and ESA is planning to keep the developing of these tools beyond 2027. So the development consortium is the companies you see there: Brockman Consult from Germany, Skywatch from Canada, and CS from Romania and from France. Snap provides with the necessary tools and services to work with EO data, and the ecosystem comprises 10 elements from which we can highlight the website with a user forum, as I told you, tools for quality assurance, repositories of software, and extensive documentation. Snap is based on a graphical user interface, and this is mainly used for data visualization and fast analysis of the data. Here are some examples of a Sentinel-2 product, together with some tools for analyzing the data, like the spectrum view. And it also has a lot of tools for data analysis. So these tools are also available from the graphical user interface that we will take a look later to it. And they are very useful for understanding the data and knowing what we can expect from this data before doing a big process, a batch process. The Snap GUI also comes with several data processors for different sensors. So there are generic processors like bandmath or map projections, or tools for binning data. And then we have more specific ones, like atmospheric correction for several types of sensors, geophysical parameter estimations, etc. Inside the graphical user interface, Snap offers a way of performing batch processing, mass processing. This can be done by generating a graph and applying it with the batch processing tool. We will see later with a bit more of detail what is, or the different ways of doing this batch processing. So this is an example of a workflow of a graph in the batch processing tool in Snap. Here are some examples of images process for generating, for instance, water indexes in this case, or this is a Sentinel-2 image water index, normalized difference water index. And here we have classification of land coverage map produced with Sentinel-1A, for instance. For supporting users, there is a forum, as I told you, with a public questions and answers, where a few experts try to answer questions or help with different problems, but also allows the users themselves to interact and help each other. There is an issue tracker for detecting and improving or reporting bugs. Right now, there are in the ESA webpage 70 tutorials accessible from the ESA webpage, and plus a few videos also published in YouTube. And for the developers, there is also a specific community. So here you can find all the links to the different resources I just explained, the forum, the tutorials, and some wiki with some more explanations. This is how the forum looks like. And as you see, it's separated by toolboxes, and then there is a general snap forum. About the system architecture, yes, to be fast, I don't want to enter into much detail. It's structured in 4 layers. There is a Java runtime as the base, and then on top we have the Snap engine, and it provides a common functionality, the product data model, the processing framework, and the API. And on top of this, we find the NetBeans, and then the Snap desktop, and on a parallel level, the Snap command line. So the Snap concept is based in different toolboxes. So the source code is split in different modules, and those modules are integrated by using plugins. So this means that new developments can be easily included. There is also a continuous integration and quality assurance for the Snap developers. So they are using a state-of-the-art system for continuous integration, fully automated tests with large test coverage, tools for system monitoring, and a security layer that includes secure storage of the credentials of the users, antivirus, anti-malware, etc. What is expected in the near future? We hopefully deliver the Snap 10 version by the end of this month. That means in 2 days, if everything of the test goes right. And there are further improvements planned for this and next year, at least until the end of the 2024. And one of the main novelties will be the start with the integration of other images, or other images that come from other sensors like Shime or Simmer. And as you see here, some NISAR and biomass satellites too in the near future. So you can download Snap from the step.isa.int webpage. As you see here, there are several, you can download all toolboxes at once, or you can decide which toolboxes to download. We have Sentinel-1, Sentinel-2, Sentinel-3 toolboxes, and other toolboxes specifically for SMOS, for instance. And it can be downloaded for the 3 different systems available now for us users, Windows, Mac, or Unix. And I'm going to make a small, I have a few slides and a small videos, short videos with some of the capabilities of SNAP, specifically for the Sentinel-3 toolbox. The Sentinel-3 toolbox is the one that is ingesting the OLTI and SLSTR data. And this is important for us, or for the ocean color community, because, as you know, OLTI is the sensor for the ocean. But it also is able to ingest other data like Envisat Maris, the predecessor of OLTI, AATSR, and MODIS, SEWIS, VIRS, NASA sensors, and other specific missions like PROBA-V or SPOT VTG, Landsat, etc. So I already told you about some basic functions like bandmath, statistical analysis, spectrum analysis, but there is also a specific exploitation of the information provided by the uncertainty. So there are uncertainty bands included in most of the products, and you can work with these uncertainty bands in SNAP. And there are also processors for working together with different types of sensors like OLTI, SLSTR, or the synergy products. For instance, the collocation tool or the pixel classification. So for the presentation today, I downloaded the data from the UNetSat data store. If I remember properly, in the first block of these webinars, Ben Lovedays show how to access this data in the catalog and then download manually and automatically from the UNetSat data store and other services. So I downloaded the data from this. I downloaded L1, level 1 data and level 2 data, so radiances, and then biogeophysical parameters. So what I'm going to show you is how to start working with this data. And to start working with this data, what we need is to open the data and to visualize it and to see what there is inside. So this is the first step, and I will tell you some visualization tricks that you can do with SNAP. So this is how the graphical user interface looks like. In the Mac, the menu is on the top. So this can differ in Windows or Linux. Snap can import and read multiple data formats and imagery from several satellite sensors. And from the file import menu, we can see that there are optical, SAR, and other raster formats that are ingested into Snap. Vector data can also be ingested, but you need a raster as a basis. For simplicity, I will open an OLTI-L1 full resolution image and show you some basic functionalities. So I will open it by selecting the XML file inside the image folder. In this case, it's a Sentinel-3 or safe format. So it will take a little while to open. Most of the functions that I will show you here can be used in similar ways in other Sentinel optical data, and also in other NASA sensors. So the contents of the image are shown in the Product Explorer, and you can open one band just by clicking twice on the image, or we can open an RGB composite by clicking on the name of the product, a right click on the name of the product. And there are several RGB composites that you can use. By default, we will select this 3 stimulus to see the whole area in a near to truth combination. So this is the image I have selected. We will see later where this is located in the world. So we have a navigation window that allows us to move around in the scene. We can zoom in and zoom out. We can also do that from the main window. not only from the navigation, but here in the navigation, you can see how to move this rectangle around the image and to have a first visualization of it. So we are in the Bohai Sea. You can see that, where is that the China Sea in general. So this is the location, the footprint of the image appears in the world view. So we see here the Bohai Sea, the Yellow Sea, and also the East China Sea. And there is a very interesting area by the coast of South Korea that is really very bright and also polluted with sunglint. We also see the high sediment content in the coastal water by the mouth of the Yangtze River. And even we are able to see, well, clouds and something in the water in the Bohai Sea. So I will show you now how to process data. I have downloaded the level 2 data from the UMETSAT data store, but I will perform atmospheric correction and an estimation of geophysical parameters for water quality using Case2RCC. Case2RCC is an algorithm that corrects for the atmospheric effect, so it transforms the radiances into reflectances, and at the same time estimates in water parameters, and is available from SNAP. Case2RCC is based on a neural net that is trained with a big range of data types and inherent optical properties. There is a bioptical model included, and it is trained for areas that are especially complex, like the one we have seen in the image before. I wanted to highlight that Case2RCC is an open project, and there is a web page with details about the ranges of the neural nets use, and also the documentation and the contact for possible collaboration. I mentioned in the slide also EDEPIX is a pixel classification tool that is available from SNAP, and you can use it before applying C2RCC, for instance, or after. So what I will show you here is just, well, first we will open one of these bands of the band 5 of this level 1 product of OLCI. And we are going to stretch a bit the histogram for a better visualization. This is possible too from the color manipulation window. And what we are going to do before applying Case2RCC is to make a subset, because the area is huge. So just for doing it faster, we will only select one area. And I was very intrigued by these bright pixels near the coast of South Korea, so I want to select my area there. I can subset from selecting the tool from the menu or right-clicking on the image. If I right-click on the image, I can subset the spatial subset from you using this tool. If I wanted to subset, for instance, only some of the bands or the type of greens, or not including the metadata for whatever reason, I could do it too. But so far we just take everything and just subset spatially. And it will be by default open in the Product Explorer. So you can see the subset prefix here, and we can open now one of the bands, or the same band, and see that right now in my image, I only have this small area that I have selected for as region of interest. So we are now going to process the data using Case2RCC, which is included in the optical menu. And thematic water processing, here it is, and Case2RCC processors. Also, you see there are other processors that can also be processed with Case2RCC. So there are several parameters that can be adjusted. I can put, for instance, if I have it, ocean and air pressure models, in the input label. We are not going to save as DMAP because we save sometimes in this demo. And the name of the output adds by default a suffix that is case2RCC that can be changed with desire. In the parameter label, we can change and adjust the valid pixel expression. This valid pixel expression is the one that comes by default. For instance, on the process pixels that are land or clouds, or if you're using EDPix, you can use some of the flags that EDPix is also putting here. So we can also modify the ranges of salinity, temperature, ozone, air pressure, etc. if we have it for our region of interest. And if we know what are the factors that for a better calculation of chlorophyll and total suspended matter, we can also change them. For the outputs, we can also have a big selection of outputs. We can save some intermediate products like TOSA or transmittance or attenuation coefficients. And we can save as reflectances, remote sensing reflectances, or as water leaving reflectances. So the generated product will be open in the Product Explorer 2 by default. Okay. And I will continue with the presentation. So I will open the image, and so we have the open here. The case2RCC is the default suffix. So just to show you some of the functionalities that Snap has, I'm going to show you a couple of slides comparing the results of the case2RCC processing with the standard L2 processor. So the images that are delivered by UNetSat automatically. So I will show you just using the window, tiling window, or using a collocation processor. So we can tile the images and put these two images together and add a color scale to the data we have. And in that way, we can see the differences that are easily, in this case, observed in between the chlorophyll concentration product derived by case2RCC and the OC Forme standard level 2 from UNetSat. So for instance, we see differences in the masked areas. In this case, in the standard product, the area of our interest is complex or bright waters near the coast of South Korea are masked because they are considered clouds. This doesn't happen in the chlorophyll neural net derived by the case2RCC. And it allows us to see some of the things that are happening here. In any case, even if there are differences, this doesn't mean these values are right. Okay, we have to be very careful in these types of areas where we have bright reflectances that could be related to sunglint or even clouds or other things. So, but this just to show you how you can compare these things. The collocation tool is also very interesting and is available from the raster geometric menu in Snap because it allows to put all the bands of the two products together. So we can compare both products with a pixel info. So I have here the values for 1 pixel of the chlorophyll product for the neural net, in this case case2RCC, and the OC Forme product. So this collocation tool is also very useful for working with different types of sensor. If we want to relate, for instance, SST and chlorophyll in this case, or TSM or other parameters, we can also do it using this collocation tool. By the way, there is a dedicated tutorial about ecolocation in the ESA webpage. And as you see here, there are other tutorials concerning the Sentinel-3 toolbox, like whale correction or the data conversion and export. And there are other tutorials in general for the Snap capabilities, some basic tutorials about basic functionalities, and some other examples about how to process in bulk, for instance, or exporting data or importing data, etc. Another functionalities that I find very useful when I work on coastal areas, for instance, is the possibility to clip an area using a save file. This is done by the function that is stored in raster, mask, and land water mask. And for instance, for doing some coastal or changes in coastal lines, analysis of these changes, this is quite useful. You can also select this area of interest by just drawing a geometry and then clipping your images using this save file. I also find the Snap tools very useful for validation of products. Validation with external data is possible because there is this possibility of importing vector data from a comma-separated value or a text file with your in situ data. So if you want to check how good is your product and you have in situ data, you can do it in Snap. So you import this vector from CSV, and the in situ data points appear overlaid on the image, and you have available some statistical tools like this correlative plot, where you can analyze the correlation between the two parameters and derive the formulation, equation, etc. And another tool that is very useful for scientists, and we use it a lot, is the pixel extraction. With the pixel extraction, you can read a CSV file with the latitude, longitude at the time of your in situ points, for instance, or points of your interest, and it looks for matchups on a series of satellite images. Of course, you have to have these satellite images in your computer for the tool to find the matchups, but it allows to extract a central pixel or a macro pixel, usually of an odd number, 3 times 3 or 5 times 5, with the center on the indicated latitude longitude position. And then you can select a time difference, so 3 hours or 12 hours, 1, 2 days, etc. And you can do this pixel extraction, this matchup extraction, without any further aggregation, or you can calculate, or you can extract the mean or the minimum or the maximum or the median of the macro pixel. So the file is stored in a CSV, and you can open this CSV file with Excel or Python or MATLAB and use it to do this type of time series analysis, for instance. I wanted to spend the last few minutes in explaining a bit how to use Snap for batch processing, because the graphical user interface is very nice and very useful when you are starting to work with data and when you want to analyze the data and see what can you obtain from them. But once you have everything clear and you need to work on a long time series, is better to do it. Is better to do it the most automatically the possible. So you use. There are several ways of using Snap in batch mode, and I will go through them and explain a bit how this works. So the first one is the graph builder. The graph builder is what in names says, is you are going to build these types of graphs. This is available from the GUI, and these safe graphs can also be used outside the GUI with a line, with a command line with a graph processing tool that we will see later. So this graph builder allows the user to assemble graphs from a list. There is a list of available operators and connect these operators nodes to their resources. So for adding a node, adding one of these processors, we have to right click on the panel, add the operator, and once the operator is added, you can link it to the source, to the data that is going to be processed with this node, with this function. Every node, except for the first one, the reader, needs a source. That's quite important. So we can use this graph in the graph builder to run the data from here, or we can save it and then upload this graph in the batch processing, also available from the GUI. I'll show you in 1 minute. And before the graph builder of each operator calls each operator to validate its parameters before it's saved. If there is any mistake, it will be, or any problem, it will be shown in the graph builder. This is the XML file that is generated. So this XML file is equivalent to this graph. So this is the XML file that is generated when saving this graph. So once the graph is ready and is saved, we can open the batch processing tool, also available from the tools in the GUI, and we can open or load this graph and select the data that we want to process with these different functions that are stored in the graph. And next, what we have to do is just to tell the processor where we are going to store the outputs and just run the processor. So I made a short video showing this. I think we still have time, so just for you to know where the graph builder is from tools, and then how to add an operator. I'm going to use the subset processor, and moving to the left of these nodes, this circle, red circle, will appear, and it will allow us to link the source product with the processor, like this. So we read multi-data, we select an area of the study, and we write a new product, okay? We can view how this XML file is written here. And this is the XML file that is going to be saved when we save the graph, okay? Yeah, and then we go to the batch processing. So in the tools, we save it here, my graph. And in the tools, we go to the batch processing, and we can load the graph. And with the plus, we have the processor and the right labels, and we can run. Once we have all the images in the inputs, we can run the batch processing from here. So there are other possibilities of batch processing using the graph processing tool, the GPT. So this is outside the GUI using command line tools, and we can do it in several ways. So we can just write a command line in shell and run the GPT. We can create a script, a shell script, and run it on the command line. Or we can integrate these scripts in Python or IDL or MATLAB, etc. So the advantages of not using the GUI is there are no intermediate files written. The graphs are reusable, so there is a reusability of processing chains and operator configurations, and it's simple and comprehensive operator. The configuration is simple and comprehensive. So to run the GPT, we need to locate the snap bin directory and open a terminal. So we go to terminal, just using this GPT-H command, we have a list of all the operators that are available from the GPT. Not all functions that are in the GUI are available from the GPT. This is something you have to know. And only those operators whose plugin has been installed in the Snap will be shown here. This is also important. In the Snap bin directory, we also have another two tools, the pconvert. pconvert save is a way of saving automatically images in different formats like VMAP or image formats, PNGs or etc. Usually it's used for quick look generation of images. And then we have the Snappy configuration launcher to configure the Snappy, that is the other batch processing tool that I will show you in a bit. So as I told you, to understand which operators are available, you just have to do this GPT-H. The usage on the command line is usually to indicate that you're using GPT, to load your XML file or your graph, and then to indicate what are your sources or where are your sources, what kind of images are you using. And I already said this, so we can move to the next slide. So this is an example on how to use GPT from command line with only one image. So this is the way of the syntax that Mac uses, is dot/GPT. In Windows, this differs. Then you have to indicate where is your XML file, the one you have created in the graph builder, for instance. And then you have to indicate the source. So what is your input data? And with this -T, you also indicate the output data. So in this example, I was using an Sentinel 2B MSI level 1C, and I was applying resampling of the data to 10 meters or 20 meters, for instance. You know that, or if you don't know, I tell you, Sentinel-2 MSI has different bands with different spatial resolutions. So usually to work with them is always better to bring everything to the same resolution. So, and then I did a subset for an area of interest and applied the K2RCC processor to obtain a level 2 reflectances and water quality parameters from the Sentinel-2 data. Using this same idea of the XML with shell, what we can do is to generate shell scripts, and this will run on not only on one image with one command line, but we can copy several command lines in one file. We will need to change the input names and the output names to do that. We can use Excel or other editors to do this. And then we save as BAT in Windows, or we save as sh in Linux or Mac, and we can run it directly from the terminal. Another way of doing this is just generating a proper shell script, also with indications of the output and input products, and just do a for loop to run on all over the images we have in the input. Or we can integrate this in, for instance, a Python Jupyter notebook. So it's basically the same. It's calling the input path and indicating the output path. Where is my graph? Where is the GPT? And integrating this into Python. So it will process all the images that you have in your folder, and it will apply, in this case, the subset, idpix, case2-ACC, merge, etc. There is more information about how to do batch processing in the wiki, Confluence. So there are some examples for Windows, for Unix, etc. And there are also two other options to run snapping batch processing with Python. One is using Snappy. Snappy is a bridge between the Java in Snap and Python, and allows invocation of Snap functionality from Python and vice versa. The GPF processing graphs can be also created and executed with this Python if preferred over the other options of the command line. So I show you a couple of examples of the use of Snappy. For instance, in this case, we are reading a DMAP. DMAP is the default Snap format, and we save it as a PNG of only one band. So in this case, we introduce so we are here selecting the functions we need to do this. From Snappy, import products, import output. So we select the image we want to process. In this case, is Mary's image, full resolution, the 1B subset. And we select only one band, the radians 13. We have to indicate the dimensions of this image. And then we can plot, for instance, if we want the data, and then save as a PNG. So this would be something very similar to what pconvert is doing on the command line. Another example in this case is reading a safe format, that is the standard format of the OLT images, and save in DMAP in the snap format after resampling to 10 meters. So we read this product here, and we select the resolution we want to resample the data, and the models or the equations we want to use, and then it's just saving this product as a DIM. And to finish, we have the Snapista. Snapista is based on Snappy. It's dedicated to create and run these graphical processing graphs in a Pythonic way, and it's provided as a conda package for Linux. So it's still an external tool, but the idea is to integrate it into the Snap ecosystem in the near future. It only works for Linux so far, but you can use a Docker container to use it in Windows or Mac. So examples of the Snapista, and this is the two slides that you have now is a whole script. So first, an read operation node is added here, and then in this case, apply orbit file is referring to the Sentinel-1 data. In this case, we are using SAR data in this script. And so we have calibration operation, a terrain correction, and then the product is also right. And finally, you have to put this processor for running the graph. Okay. If you see the syntax is close to the XML syntax. It's not the same, of course, but that's at least the idea, not to write this algorithm, this process in an algorithmic way. So further reading about Snappy, there are more examples on how to configure Snappy, how to use the Snap API from Python, and how to write an operator in Python. You have the links here. For Snapista, also you have the installation and the getting started guides in these links, and some examples on how to use the operators in this link too. So this is the end of my presentation, and I think I've been probably too fast. But it's now time for questions and answers. Thanks for your attention. And I hope that Tom, my colleague, will show up and help me with this part of the presentation.
Tom, you are muted.
That's what I get for having a mute on my mic as well as a mute button. Okay. I was just saying, sorry. Thank you very much, Anna. A lot of material covered there, and we had a decent number of questions. So I think we may make use of those 5 minutes, extra 5 minutes we've got for questions. So that's okay. I don't yet see Thomas. It's Thomas Block, right? In the
I'm telling him to join us.
Okay. So I'll keep an eye out for him. We can make him a panelist as soon as he arrives. In the meantime, so there were a couple of questions around that I think were almost answered as you went along, but maybe just to check if we had those in the chat, the links. There was one about the location of tutorials. So I think you had a web address for that. So I think that's been pasted into the chat. And there was also one about where to download and get the program, and that was also put in the chat as well, I believe. So hopefully everyone's got access to what they want. So I think before we, I guess Thomas will be answering more questions around Snap itself. We had a couple of questions around processing remote sensing data, which is, I think, is definitely something we can speak to without Tom. So one of those was asking about, you showed a number of examples of processed data sets. We've had a question about processing wave data, I guess, so that would be using Sentinel-1, I guess, to get swell heights and things. So as far as I understand, you just need to make sure you've got the right plugins for Sentinel-1. And then
yes, you have to be sure that the Sentinel-1 toolbox is installed. Usually, if you download all toolboxes, it will be installed by default. But then you have to be sure that from the window from the tools menu, there is a plugins section. Maybe I can share my screen.
That might help. Yeah, I think a lot of these might be.
Okay. I do that. Wait a sec. Okay. Can you see my screen now?
Yes.
Okay. Snap is open.
Mm-hmm.
With the product explorer, visual info, the viewer. So from tools, you have the plugins. And these plugins, there are many that are also installed by default. usually when you install Snap, it checks for the new plugins, or every time you open Snap, it will check for the new plugins and it will ask you if you want to install. In any case, if you skip some of them for any reason and you want to recover them, there are always this list of available plugins or information about the installed plugins. Or if you have something that you have developed yourself and you want to include it, you can also add plugins from this tool. Okay.
Great. So yeah, if you're interested in ocean swells, then make sure you've got the right plugins and look at Sentinel 1 is the answer to that one. There was, it might be, Tom might have a better answer for this. There was a couple of questions that we tried to answer in the chat around some people on Macs recently have had issues with Snap pop-ups not appearing properly. As I understand it, one that should be fixed for Snap 10, which he said is going to be released very shortly. So that shouldn't be a problem. For those in the meantime, I've posted a little few steps where you can, there's basically a tweak which has worked for a number of people, where you move one of the subfolders within Snap out, try and start Snap and then move the folder back, and that seems to fix the Java issue. But it shouldn't be a problem for long, because as far as I understand, it's fixed in Snap 10 anyway. So hopefully it won't trouble people for much longer.
Can I just say how delighted I am to hear that this is going to be fixed soon, because the workaround is great. I don't know who came up with that and how they managed to figure it out, but very, very happy to hear that Snap will be working again on Mac.
Yeah, I hope so too. So we have been doing the testing these last weeks, and everything looks fine so far. There are still a few things that need some change, but I think the next release will solve some of those main problems.
We had a couple of questions around the C2RCC processor. One of them was asking, is there a maximum chlorophyll concentration that it can estimate, or that we might say beyond that value, not trust the values anymore? The
ranges are in the Snap community, in the C2RCC community webpage. I don't have it ready. Here we have it. So there is information about the nets and the ranges that they cover by sensor on this webpage.
So sensor specific. So okay. Yep.
Yeah, it's sensor specific, and also some information about the IOP conversion to concentrations, etc. So okay. I cannot really answer because it depends on sensor, but the information is there and it's public.
We've had that a lot in this lecture series. Is we get a question that looks simple and you say, well, that depends. So I think that's the perfect resource there to go and look at those. Another one relating to the C2RCC was a query about whether or not it uses the dark pixel assumption.
It doesn't. It's a neural net. It's it's fit in the spectrum. So it's
There was a query around, so I think you mentioned in your list of sensors, well, someone wants to process OceanSat 3. Was that in your list of big sensors that we know Snap can handle, or is that currently not in the list that it's kind of already built?
Yeah, that's a question for Tom. Sorry.
Okay, that's fine. We can wait for Tom on that one. Let me check the.
I told him at 2 p.m., so maybe he's not ready yet.
Don't see him in the chat yet. Okay. There was a question around trying to download images that have low cloud cover. Now, this is not a thing for Snap, but I think if the person asking that goes back to look at the talk by Ben Loveday on data access, you can put into your query cloud cover, so you can look for cloud-free images, or mostly cloud-free. You could say 70 or 80% cloud-free. So that's not something that Snap will be helping you to download those images, but the software that exists already, the APIs do allow you to specify that. So I'd recommend going back and look at Ben's lecture on data access for that one. We did have a question about whether or not, so at the minute for Snap, you have the Snap processor on your machine and you have to download the data locally to your machine. At the minute, as I understand it, if you want to do things in the cloud, you would have to make sure that basically Snap is installed on those cloud machines close to the data. There's no way of getting, sending your processing to the cloud from your Snap instance. But I think what is useful is while you're, let's say, playing and working out what you want to do with an image, you can do it locally. You can build these graph files, for example, and then you can send that to the cloud. And that's all you need to send is just that list of operations. Is that right, Anna? Or
well, I think you have to have Snap installed.
Yeah, so if we have
in your
Snap installed
server,
if we have Snap in a cloud instance.
Yeah, these technical questions are really over me. So,
Okay.
yeah. I usually, what I do is use it locally.
I think that's how a lot of people are using it. The cloud instance would probably be for really, really large processing that someone can't do on a single machine, if they only have access to a laptop. With that, there was a question about the laptop power, or let's say the capabilities of the machine to run it locally. As I understand it, Snap, it looks at the resources that are available and tries to make use of those. So you can run it on a slower machine. It will just take longer to process things. You don't
need some RAM data. It's better to have at least 16 gigabytes minimum.
Okay.
RAM.
Okay.
Because but we are working with big images, and the rendering time and the visualization tools are they need a lot of this memory.
Okay, so
of course, if
is there a list of recommended specifications for a machine to run it, or is that, would we recommend mostly just 16 gigs of RAM and then?
I think with 16 gigabytes is fine.
Okay.
But if you are doing if your processing is really like a long list of things to do on one image or several images, I would recommend to go for the batch processing using the command line or the GPT or all these options, because that really makes the processing faster and it doesn't consume so much memory.
Can I add to this? Is that okay, Anna?
By all means, that's why we have a panel, right?
I was one of the first beta testers of Snap, and I remember I was trying to process a single image, and I had enough time to go and get lunch. I think it took 27 minutes to do one step in a 4-step processing chain, and things have improved dramatically since then. But I've also taught in a variety of countries using Snap where people maybe don't have access to very good computers, or the computers are very old. And Snap is quite heavy. It does use a lot of resources on your computer. And I will say, if you don't have the best machine, for example, I make sure that everything else is closed when I'm doing data processing in Snap, so that it has I don't set it up to fail, and it will fail if it runs out of RAM or memory. So you should just give it its best chance. And I would recommend closing other things if you are going to be doing some heavy data processing in Snap. It does require quite a lot, but it is certainly possible, even on rubbish computers like mine, as long as you don't give it too much to do. If you've got PowerPoint open, Excel, your email, and you're watching YouTube videos while you're processing in Snap, something's going to give. And just give Snap a good chance by making sure other things are closed if you can.
Yeah, thanks, Lauren. I think that's a very nice advice.
And it's getting better with every release, Anna. I mean, as I said, I remember when it used to take such a long time, but every single release, Snap just does better and better. So we're very lucky to be at this stage already.
There was a question around whether or not Snap has the ability to do things like distinguish phytoplankton groups or things like that. I know there are image classification tools within Snap, right?
Yeah, they are. They are, but you know that phytoplankton groups, it depends on how you want to do the classification. Because in some cases you need like IOPs or, I mean, it's a difficult question to answer because can you do phytoplankton groups with standard level 2 alt image? Probably not. Or I don't know, something.
Yeah, I mean,
it depends.
it
You have to
depends.
define what is a PFT or phytoplankton community before, and then decide. But yes, there are classification tools that could be used. There are supervised and supervised.
Yeah, if you because you're still showing your Snap screen, if you maybe click on the drop-down menu, people will see the list of classification tools available. Yeah, so we've got.
So from the raster, you have the unsupervised classification to cluster data. That is always a good exercise to do first to understand your data. And then supervised classification with several classifiers based on machine learning. So like random forest or KNN and other tree classifiers. So there are also segmentation tools, chain detection. There are really many tools for processing raster data in general, not only optical or radar images that have their own labels.
So there's a question about after processing the C2RCC, are there any recommended steps or precautions before merging images? So if we go to then kind of a compositing stage.
So averaging reflectances is always a bit dangerous. But if what you want to do is to use concentration products, for instance, I don't see much of a problem. But maybe some of maybe Lauren or Shuba wants to add something in this. I mean, probably it's always better to do the mosaicing or the integration or the binning first and then run the processor. I'm happy to hear other opinions.
There is a very simple method that Bob proposed where you can go from chlorophyll concentration to at least size classes. It's a matter of writing a couple of equations and then producing size class maps, starting with the chlorophyll. That should be possible in Snap, I would think, if you have the equations for your area or the ones that you decide on.
I think there you're talking about PFTs and things again, right?
Yeah, for the PFT, that was,
okay.
Unless I missed it, I thought that was the question. Can we get?
No. So so that's there's one we moved on to a different question.
Moved back. Sorry, I missed it. Okay.
Which was any precautions. So say we process 3 or 4 images with C2RCC, and then we average those images or we composite those images. Are there any precautionary steps we would take beforehand? I mean, one of them would be making sure that we've applied any recommended masks, those sorts of things before merging. But it's just if there's any other points you'd like to raise.
Sorry, I thought it was still on the context of the other one. Okay, sorry. I can't think of anything specific to CCRS.
Yeah, I mean
C2RCC, sorry.
C2RCC, yeah. I mean, I think so. Someone's mentioned that you can get negative outputs for reflectance. from the C2RCC, maybe.
I don't think so.
But normally, I mean, negative reflectances are physically impossible.
In that case, I mean, it's a problem that comes before merging.
Yes.
I would suggest don't work with negative RRS.
You would mask those, I think.
Yeah.
I mean, I would say definitely, if I can add to that, I personally have not done merging in Snap. I think for me, Snap, there is a point where doing processing should move to notebooks. But I haven't done something like this in Snap before. But I will say one of, I think, Snap's strongest and most brilliant capabilities is how easy it is to apply the masks and how much flexibility there is about masking. And if you know your area very well, which hopefully you do, you'll know which masks are the most relevant to apply. And if you are getting negative values, I would say that there's probably a mask that you've missed, probably around glint or around cloud edges or something like that, because there shouldn't be negative values. That shows that something's gone awry. And it might be worth playing around with your masks, with your, I assume you're talking about Sentinel-3 Ulchi data, applying your masks, testing your different masks and seeing how that applies. So here's I'm sure you can give a good example here, but masking is really, really key if you want to maintain sort of accuracy.
Yeah, and I think when Anna was saying about binning, you can bin the data in using Snap. It has a binning functionality. So if you process a whole bunch of images and then want to bin those onto a common grid, you can apply the masks as you bin. So it will mask each of the products.
Yeah, that's what I would do, definitely.
Yeah, concerning what Lauren was explaining, is these are the masks generated by the K2RCC, and these are the masks from the L1 product. So you really have all kind of quality flags, labels that are saying maybe you should think twice before using the information in this pixel.
Yeah.
So that's the way. The good thing is that these flags are automatically converted into masks in Snap. So they are very easy to overlay and to see if you can trust some of the data you have or not.
Absolutely. I think this is really one of Snap's beauties, is the ease of mask application, really being able to visually connect with your data and see where you feel confident and where you think, oh, that doesn't maybe look right. This is a really nice functionality of Snap that I use a lot to trust my data.
I don't know if you have used this functionality much, but for the change detection, that requires you to have all of the data locally for the change detection and time series analysis. But I guess if you're having issues with data volumes and things, you can, Snap has subsetting capabilities as well, right? So you can subset areas and then do your change detection. I haven't used the change detection, I think, within Snap. I don't know if you have, Anna.
I haven't.
Okay.
Maybe Tom is now in the crowd. Maybe.
Is he?
Yeah. Maybe he has something to say, but I'm sorry I cannot help.
There is, yeah.
I've added him as a panelist.
Well, I can say first hi, just to introduce. I'm one of the engineers behind Snap and doing the software development and all that stuff. Unfortunately, I'm quite new to the Snap right now. I was there in the beginning when it was called Beam 20 years ago or something like that, and made up the basic architecture. And then I stepped out and just came in recently back. So actually, I cannot answer this because I haven't done it. But you can, as Thomas said, you can subset if you want to have a small region. You can use a batch processor to subset your data if you have a large stack of data. And we have access to catalogs on the agenda for one of the next releases, so that your not really bound to have all data locally. So we are working on that. Maybe.
Okay, I think that's a couple of people were interested in whether or not, you know, remote data access would be
Yeah,
would
we're
be
working on
so
that.
that's really interesting to hear. Great. There was another question that came up, Tom, that Anna was waiting for you for was about the list of sensors that can be processed. There was a query whether or not OceanSat 3 is on that list or not currently, and if there's plans to include it if it isn't.
Not that I know at the moment.
Okay. Okay. But that doesn't
It's
mean,
not.
you know, if the data's in NetCDF format, you could still read it in and process things, right? It's just not got default. Like...
Yeah, I mean, if it's this always if it's in a common format like NetCDF or ZAR, it's Snap can open it, but does not do the full interpretation of all the metadata, and probably will not apply automatically be able to apply mask because mask layers are not detected as those. But you could work as if it was in a standard like MATLAB system or something like that. You could open the data, process, but not take full advantage of Snap being able to interpret the satellite data.
Yeah, so tools like Edapix, you know, we have an Edapix for Olchi, we have an Edapix for Meris, we have an Edapix for I think Modis as well, and a whole bunch of others. But yeah.
And those make full advantages of that they know where the center bandwidth is and all that to optimally apply the algorithms, which is not possible for a generic NetCDF file.
Would it be possible to take a request back to Snap developers and team and whatnot to include additional sensors such as the OceanSat 3, OCM3 kind of ocean color sensors?
Of course, this is possible. We have an open forum where everybody could write suggestions, ask questions. Anna, did you spread the link to the forum? Okay. This
Yes,
is
I did.
where we are constantly watching what the community wants and occasionally help if we have time. The problem with additional sensors is that in the end, Brockman Consult is a company, so we need to have some funding for that. And either ESA or someone else has a budget for this or not. And if not, then I don't see reasons. I don't see means to implement something like that just for free. But we are discussing with ESA. If there's a strong demand, we will of course get a work package done. It should be possible, but it's not cheap. I mean, software development is not something cheap. So.
Yeah, I agree with that. So it is a big request. So my request was for Brockman to pass it on to higher levels in ESA.
Yeah.
So that it becomes possible.
Yeah, I mean, just drop a mail to me about the real requirements, detailed requirements, and then we can discuss this with ESA.
Tom, the request from the participants was very clear. They would like to use ocean color, what is it called? Ocean Color Monitor, OCM3 from ISRO. And
Yeah, I mean,
would
I
it
think
be
if
to process
all
it within Snap?
if a number of these attendees go and, you know, put the request in on the forum, and then, you know, BC have a case to take that as a point to raise with funders, then there's a clear path there. It's I mean, I will recommend that the forum, I think, is a very good thing. It's the level of response is very high. You know, I've seen people post questions and get responses very quickly. So yeah, if you are using Snap and if you are having problems, don't suffer in silence. The forum is there, so use it.
The forum is good, but some of them may only go to the forum if they know initially that Snap will do what they want it to do.
Mm.
So it's like,
But there are ESA staff in the forum too.
yeah.
So yeah. In any case, we have also to understand that the Snap is an ESA toolbox and is it's a project, and it's more focused on the Copernicus program. So this have somehow the
I do understand that, but
they are
not,
the favorites.
but NASA sensors are in there. So anyway, I sympathize with those who ask the question. And my request is for ESA to go beyond ESA and become a global provider of services.
Mm-hmm.
But actually, my question is more complicated than that. The first step for ESA or SNAP to be able to do the things would be for you to have access to the data. So it goes beyond ESA and ISRO.
Mm-hmm.
Okay. I've made my point. I'll keep quiet now.
Yeah, thank you.
The next topic for discussion, let's say, there was a number of questions around comparisons between Snap and Google Earth Engine, or things like, can we use C2RCC in Google Earth Engine, or these sorts of things. So obviously, GEE is a tool that I think has seen a lot of uptake, but in my view, and then I'll open it up to panel discussion. There's two main functionalities. One of them is taking an image and investigating something visually, like we're doing here, and maybe statistically as well. And then the other one is the big batch processing. And Snap has capabilities for both. The question is, I mean, really boils down to the difference beyond the coding language being different, is that everything for Google Earth Engine you're trying to do in the cloud, and at the minute, everything for Snap you're trying to do locally. But as was just said by Tom, there might be plans coming for Snap to do things on data that isn't local. But I don't know if anyone has any. I haven't used Google Earth Engine very much, so I don't know if anyone wants to comment on similarities, differences, pros, cons.
Well, it's something that we need to conceptually decide with ESA. For now, the idea is you have a desktop engine as a normal user, and we try to extend the data access to the external, like that you can query catalogs and download just the subsets you're interested in. Remote processing is something we will do some tests, but surely not on Google Earth Engine, because it's not a Copernicus service. So there is no funding for that, although it's interesting. It's conceptually interesting. We will do some spikes to see how remote processing on Copernicus services will work, but most likely not this year. We have, I mean, Snap can do mass production. We do this all day, but on specific hardware, and this is not open hardware. We can. We have our cluster in the company. We are using some clusters in the cloud, which get a specific software layer installed by us and then run Snap processes. But this is not something that someone without in-depth knowledge on how things work can handle. And the problem is that it's complex. If you go to a parallel system, you need to do job scheduling. You need to do handling of failed jobs. You need to define a batch, submit it in a kind of a useful parallelism, and be able to react on that. You need to gather the results back again. All this is not easy. This is in-depth mass production, and to shield this in a way that Google Earth Engine tries to do is hard to achieve. They can do this easily because they have a huge batch of developers in the background, and they defined a very small interface that allows you to supply JavaScript code and do something with that, and then have an internal dispatching. Right at the moment, Snap is Java, so this clashes a bit, and let's see. I see the demand. I mean, we are on the step that we need to do the put the algorithm to the data. There is no choice to do that. I mean, the resolution of sensors is ever increasing. The amount of data that's downloaded from space is ever increasing. I mean, even we as a company, we have sometimes difficulties to store all that stuff, to do some annual processing. So we need to do that step, and it is planned, but not in the near future.
But yeah, and I think so. Pedro in the chat has raised a point that I think is can't stress enough. So he said that GE doesn't have the capabilities and algorithms that Snap has, and I think that's one of the real strengths of Snap, not just in ease of use and the layout is easy to navigate and these sorts of things, but the amount of scientific knowledge that's gone into developing the codes and the applications so that you can apply an atmospheric correction or something very simply is massive. If you have to code that up yourself in GE, I mean it's just a monstrous task. So yeah, so I think GE, I've seen a lot of stuff for things like Landsat, where people have been applying simple difference algorithms and things to Landsat data. But I think for the applications that we're looking at here, particularly ocean color and in water products and things, the amount of scientific applications that you have access to through Snap, the plugins and all this stuff, is really useful. And I would hate to have to try and recode any of that into GE. Okay. Any more questions? We've had a couple. There's one about is there a common platform to get Sentinel derived products like chlorophyll? I think so. If that question is asking about if there's a single place to go to for, let's say, Sentinel chlorophyll products, again, I would go back and look at the lectures on data provision, because Copernicus and other services, that's where they're producing those or servicing those, let's say, mass processed derived products. What have we got? So there's a question of whether or not those future plans, I guess, for remote processing would be integrating Snap with things like CreoDS or Wikio.
Yes, that is the plan.
Okay. Good. Okay, so that makes sense. And that's again, if you want to find out more about
where the data resides. So it makes sense to use a EU-based cloud platform where the data is uploaded to as a target platform.
And I think Ben even covered Wikio in his lecture, I think, briefly. So again, we'll go back and recommend looking at those.
TJ, there was also a question about the data being in the same place. I don't know if now is a good time for me to quickly address that, or if we can leave it. It's up to you.
This is free speech bit, so go for it.
No, I just wanted to say that you need to go back to my first lecture where I explained that a lot of the services are divided between ESA and EUMETSAT. And EUMETSAT is the marine sort of repository for marine data, and they do have Sentinel 3 JSON data within EUMETSAT. So they are responsible for making the marine data available. On the ESA side of things, Sentinel 1, 2, and some land data from Sentinel 3 are provided through ESA. So those are two separate streams, which makes sense when you look at the bigger picture because of how big and ambitious the larger Copernicus program is. However, I'm really glad we talked about CreoDS, for example, where all of that data are available in the same place and do not have a one-year rolling archive like the hubs, like some of the hubs do. But CreoDS, Wikio, these are very good repositories where the data are centralized, and I'm very happy to hear that Snap's going to be connecting with that more actively. But bear in mind, guys, there is a marine agency and there is a terrestrial agency, and even though there is overlap, EUMETSAT takes care of marine, ESA takes care of terrestrial, and that's why it might be frustrating that you go to different places for the data, but don't forget about places like CreoDS where all of the data are centralized. That's all I wanted to say.
Okay, I think we're pretty much caught up with the questions now. So there's just the last couple in the chat. So there was one about updates on SNAP training programs. So I don't know if there's somewhere on the forums or anything that would be a good link that people would keep an eye on if there's new materials or if there's new features that come online that people would maybe want to have instruction on. I don't know if that's planned.
So the forum is a good source to know about the updates and the news about Snap, and then also to ask us if there is something specific where to find data or where to find tutorials or videos. And there are also many programs from both EUMETSAT and ESA where Snap is used as a tool for imagery processing, especially for ocean color. So there's also good to check the EUMETSAT training webpage and the ESA courses. ESA delivers courses, at least 3 courses every year where Snap is used on different, not only in ocean, but also on land or even a remote sensing general course that is done every 2 years by the ESA Academy. So there are resources outside, and there are a lot of things, and I know there are many users, many Snap users that are producing also YouTube videos. So this is also a good source for training.
Okay. I think that's about it with the questions now. Oh, one we've missed. Why does Sentinel-3 have 2 water-leaving reflectances, one normalized and the other not, and what are the differences? So, yeah, I mean, this goes back to our early lectures on the basics of atmospheric correction and remote sensing. So normalization is where you try to remove any impacts of the angular distribution of the light field, so that it is the reflectance you would see from directly viewing above in the absence of the atmosphere and these things. Why do we have 2? I guess is the important part of that question. Why do we have normalized and non-normalized? Big question. Shuba, maybe you've got a nice succinct answer for this one.
I guess it is just the precursor to the normalized one.
Yeah, I mean, I know there's some applications, for example, use like Raman corrected reflectance and things like that. So those tend to be ones where you're looking more at features on the surface. So if you're looking at trying to look for things like floating algae, some of those have used like Raman corrected reflectance only, like bottom of Rayleigh, sorry. Bottom of Rayleigh reflectance.
I was going to say another thing. There are steps to go from the observed RRS to the normalized one. So if you have access to the unnormalized one, you would have the freedom to develop and apply your own methods for normalizing. But normally, if you just want reflectance and go ahead with your algorithms for in-water properties or whatever, then you wouldn't use the unnormalized one.
Yeah. So for most of the applications I think we've seen in the first, 12 lectures so far, that will have mostly been, whenever we said RRS, that's been referring to normalized reflectances. But yes, if you're interested in the angular distribution, or if you are looking at things that are happening right on that surface, some algorithms have used the non-normalized reflectance. So yeah, I guess when we're talking about using normalized, if you're looking at trying to make a new chlorophyll algorithm, if you're looking at trying to even look at things like TSM or any in-water properties, the recommendation is to use normalized reflectance, because the issue is otherwise you have a sensitivity you have an additional factor that's going to influence your results that you need to account for, which is the angular distribution of that light field, which depends on solar angles, viewing angles, all these sorts of things. The whole idea of normalization is that you can compare the observations from two satellites and they're seeing effectively the same thing.
Also, the idea is that you've removed the influence of the atmosphere, regardless of the viewing angle, and that you've also eliminated differences that arise from changes in the Sun-Earth distance as the Earth is revolving around the Sun. And as the distance changes, the flux reaching the Earth's surface changes. All those things are corrected for in the normalized one. So under normal circumstances, you would use the normalized RRS.
And I think if you wanted to spend a lot of time reading about that, as we pointed to people to before, IOCCG reports are a good source. There's also
there is also an online book by Howard Gordon.
Yes, that's the the Ocean Optics web book. Is that the one?
Not sure what it's called. Could look it up. I think that one.
That is really a good question, and I also wonder if maybe the ocean color scientists should also dedicate more time of trying to explain better what are all these parameters. Also, trying to differentiate in between remote sensing reflectances and water vapor gradients, and that sometimes appears units are different. Why these units are different? What is better to use in its case, and all these issues should be. It's an interesting discussion, and I think this is something that is not really very much taught in courses. So yeah, that's my opinion, suggestion.
Okay. I think that's just checking back through our list of past questions. I think they're all answered.
Howard Gordon's book is available on IOCCG.
Yeah. Okay.
Ocean color.
Well,
What does it say?
I think if we have no more questions, we'll leave it there. And thank you very much again, Anna, for the lecture. Thank you, Tom, for joining as well for the questions.
You're welcome.